So we are coming to preparation of salt. So I put it as the main title here, preparation of salt. So students must know that there are two types of salts. One, soluble salt, and the other type is insoluble salt. And the preparation method for soluble salt and insoluble salt are not the same. Okay, so because the preparation method of a soluble salt and an insoluble salt is not the same, so it is very important before you start recommending or start describing a method of preparing a salt. First and foremost, you must decide whether the salt is soluble or insoluble. Then only you can correctly pick the method that is required to prepare the salt. Okay, all right. Now let us go to the chemistry of it. Now, preparation of a soluble salt is the method of preparing a soluble salt. So preparation of soluble salt is by crystallization method. By crystallization method. It's known as the crystallization method. Whereas the method of preparing the insoluble salt is known as the precipitation method. Precipitation method. Okay? Precipitation method. So we have the precipitation method and you have the crystallization method. Okay? There are two methods of preparing. Okay? Now, the precipitation method is sometimes also be linked to double decomposition. All right, it's also known as double decomposition, but actually this precipitation method, all right, is actually a process. Okay, this is a process, but it's okay. You can take it as double decomposition, although there is a slight difference in terms of terminology used in terms of process and technique. This is more of technique. Double decomposition. Okay, double decomposition. Okay, we can put that. Okay, now. So examples of salt that will be done under crystallization method will be example copper 2 sulfate salt. Why copper 2 sulfate salt can be used this method? Because that's a soluble salt. Magnesium nitrate. Okay, magnesium nitrate is a soluble salt. Zinc chloride is a soluble salt. All right, under the precipitation method, salts that we prepare this method will be silver chloride. That's a insoluble salt. Barium sulfate, that's an insoluble salt. Let's say lead-2 sulfate, that's an insoluble salt. Lead-2 chloride, that's an insoluble salt. And then calcium sulfate, that's an insoluble salt. So these are all by the precipitation method. This will be by the crystallization method. So that's very clear. Okay. All right. Now, your crystallization method has 4, further divided into 4. Okay, now in the preparation of soluble salt, all methods will involve acids. So you have 4 methods to select from, and all of them will involve the appropriate acid will be involved. Okay, now one method is involving an acid and an alkali. Okay, an acid and an alkali, there will be one method. But the concept is such that in your chemistry, in your laboratory, the alkalis that are commonly present in the laboratory are sodium hydroxide and potassium hydroxide. And hence, this method, acid and alkali, is completely reserved and recommended only for preparation of sodium or potassium salts. Only when sodium and potassium salts are mentioned, we use this. Now, another way of looking at it, you know that alkali are bases that are soluble in water. And you also know that bases or hydroxides that are soluble in water are all group 1. Only group 1 bases and bases. That means oxides or hydroxides of group 1, they are the one that is soluble in water. Because of that, acid and alkali method is reserved for salts of group 1, namely sodium and potassium. Now, number 2, acid, the reaction between acid and metal. Okay, the reaction between acid and metal. Here, there's another condition. You know that not all metals will react with acid. Not all metals will react with acid. Metals whose electropositivity or the position of the metal in the electrochemical series which is higher than hydrogen, they will react with metal. So the metal that is just above hydrogen in the electrochemical series is lead. So this one can only be used for lead and the metals above it. But even then, even for lead, we will not recommend that because the reaction is too slow. Although lead is above hydrogen and technically speaking, yes, lead can react with acid, which it will, but the reaction is too slow. And because of that, that means you have the kinetic reason. Because of that, we will not recommend it for lead. So we will not recommend for lead. So we will recommend for more reactive metals. So the reactive metals will be limited to zinc, magnesium, calcium. So when zinc salt, magnesium salt, calcium salt, and to a certain extent iron, you can still use it. But as I said, these are the best. All right. Zinc and aluminium will also be in. Aluminium also will be in. Aluminium is also considered okay. All right. So, but these are the common ones: zinc, magnesium, calcium. All right. We actually that. So there are limitations in each method. As a student, you got to know the limitations and you got to know the reason why. So, as I said, the reason is not all metals can react with acid. Metals whose electropositivity or the position of electrochemical series is above hydrogen. And in this case, the metals that qualify are lead and above. But even then, I told you lead is not recommended because the reaction is slow. Therefore, we limit to these metals, which means copper and silver will not qualify for this metal. That means when I say just now, copper 2 sulfate. So if you use this method to prepare for this salt, your answer will be wrong because you cannot get a reaction. Okay, salt cannot be prepared like that. So please go through the limitations, okay? Go through the reasoning behind it. Now we come to the third method. The third method is acid and base. And the fourth method will be acid and a metal carbonate. Metal carbonate means any metal carbonate, meaning sodium carbonate, magnesium carbonate, zinc carbonate, copper 2 carbonate, any metal carbonate. These two methods are what we call the universal method. Why do we call it the universal method? Because every salt can be prepared by these two methods. There is no restriction. All right? There's no restriction. Every base will react with acid. Every metal carbonate will react with acid. All right? That means this is all for soluble. Doesn't involve that. Any salt can use these two. Therefore, they become universal. So whenever you have to design a method, therefore, all right, go for this method. This is the best method for you to pick. Now, why not this? This is more superior than this. This is more superior than this because when an acid base reacts, you only get two products. So I like that. You only will get two products. That is, you will get a salt and you get the water. So we want the salt. So all you have to do is evaporate the water out. You evaporate the water out, you will get the salt that you want. Now, if you are using a metal carbonate, you will get salt, you will get water, and you will get carbon dioxide. So there are three products. So you can say carbon dioxide is a gas, it will be liberated, which you are right. So it still comes back to this, but when you compare this, you have three products, you have two products. Definitely this is more complicated, more complex than that. Now, further to that, you must remember carbon dioxide do dissolve sparingly in water, do dissolve very small amount in water. Therefore, if you look at it technically, this is more superior than this. This is a more superior than this method. Therefore, that should be your number one method if at all you are, choosing a method for any salt. Okay, then go for this. And remember, a base is oxide or hydroxide. Okay, all right. So this is that. Now, what about the precipitation method? In the precipitation method, you do not have such thing. In the precipitation method is only one type of method, only one. There is no categorization of four, no. It's only one, and the idea is very simple. Now, you must understand in the precipitation method, the salt is obtained as a precipitate. The salt is obtained as a precipitate. The salt is obtained as a precipitate because it's an insoluble salt. So the precipitate is the salt that you want. All right? So the salt will just pop out as a precipitate. Now, what's the idea here? You have to take one salt solution, which is of a soluble salt. So this is where you got to select. So I'm going to teach you how to choose and select. And then you take another salt solution. Okay, so how many salt solution you need? 2. Both are soluble salt. That means you've got to select one soluble salt and then another soluble salt, and then you need to mix them. When you mix them, you are expecting a precipitate to be formed, and that precipitate is the salt that you want. And the chemistry says you will get another salt solution. You'll get another salt solution, which is a soluble one. So this is the salt solution, okay, that will be formed, the new salt solution that will be formed between the two. So 2 salt solutions are mixed. You get 2 salt solutions, which are new. 2 salt solutions you mix. You end up getting 2 salt solutions, which are new. But one of them is insoluble, so that precipitates out, and that's the salt you're looking for. And the other salt remains as a solution on which the precipitate lies. Okay.